Okay, so this is the final recorded lecture. I'm going to break this up in two videos. They're both about chi-square, which is for the current textbook I'm using, chapter 15. So far, we've talked about descriptive statistics, graphing, correlation, regression, t-tests, one-way ANOVA, and finally factorial ANOVA was the last chapter we covered. And now we're going to cover chi-square, because what if we have categorical data for both variables, or if we just want to look at one variable and see if the proportions are the same? Well, for that we can use a chi-square test. So for example, let's look at a full-time faculty, a sample full-time faculty members that were either tenure or non-tenure track, tenured or tenure track or non-tenure track. And we have these data. And we see, for example, that there's in all full-time faculty, 46.8% were women of a total sample of 2,774. So we might want to know, are women equally represented in faculty positions, assuming that, for example, that the general population is 50% women and 50% men. And then we can see we also have tenure track. 42.5% of women are in tenure track position, and 53.9%, so a larger proportion, is in non-tenure track. So that brings up another question: are men and women equally likely to hold tenure track positions versus non-tenure track, right? So to answer these questions, we can use two different chi-square procedures. They're both non-parametric statistical procedures. One is simply the goodness of fit test, which is a one-way chi-square, and that just has one variable, and you test whether the proportions in it are equal. So here we have men and women, so it will be 2. We'd expect 50% for both. If we have two variables, two categorical variables, such as in this example, sex and type of full-time position, we use a chi-square test of independence. And I'm going to walk you through both of them, and we'll split this video up so I cover one and then the other, so it's not so long. So first, to start with the one-way chi-square. We use this when you're just looking at frequencies, and we want to test if participants are equally represented across the variables. Okay, and this we have 2, but we could have more if we wanted. So our null hypothesis is simply that men and women in this example are equally likely to hold full-time faculty positions. So if you have two groups in your categorical variable, it'd be 50-50, assuming they're equal proportions. If they're 3, it'd be 33% in each, and so forth, 25% in 4, and so forth. Our V-church hypothesis, or alternative hypothesis, is that all frequencies are not equal, or in other words, men and women are not equally likely to hold full-time faculty positions. So there's a couple assumptions here, well, 5 technically, according to this text. First, that participants are categorized in one variable with 2 or more categories, and basically we're just counting how many, the frequency in each category. Each participant can only be in one category, so this means it's independent. So different people, remember, just like independent samples. T-tests, it just means different people in each category. Again, we're assuming we're using all participants of all responses, responses of all the participants in the study. And then we also have an assumption that the expected frequency in each group or category must be at least 5. So with that in mind, let's think about it. The expected frequency is just what we'd expect under the conditions of the null hypothesis. So if we have 2 categories or 2 groups, we would expect 50% in each if the null is that they're equally represented. So to calculate the expected frequency, you just divide the total sample size by the number of groups, which is k. So n divided by k. So here's our example. N equals 2,774, right? Groups is 2, just men and women, right? And we're looking at just this part right here. Are women equally, and men and women equally represented as full-time faculty members? So to find our expected frequency, in each category, we just divide 2774 by 2, and we get 1387. This means we expect, if everything were equal, we'd have 1,387 men and 1,387 women. So let's. Okay, so we don't actually have the numbers of men and women, so we have to use the percentage to calculate them. So let's figure this out. Degrees of freedom. So observed frequencies are what we actually observe in this in F sub O is observed frequencies, how many men and women there actually are, and that's what we're going to calculate in a minute. And the expected frequency is if they were equally distributed across the groups or categories, and that's what we just calculated. Degrees of freedom, K minus 1. So we have two groups, so 2 minus 1 is 1. So our degrees of freedom is 1 for this example. Okay, so here's what I was saying. We need to calculate how many men and women were here for our observed frequencies because it doesn't actually state it. So we see that 46.8% of full-time faculty are women. So 46.8% of 2774 is 1,1298. So when we're talking about people, we can't have, almost 3/4 of a person. So we just round down or up as the case may be. Men, so to get this one, you just go 100% minus 46.8%. We know that 53.2% of 2774 is 1,478. So there's 1,476 men. So it looks like they're not equal. Okay, it looks like they're not equal. But is this difference in men and women statistically significant? And that's how we determine this by calculating chi-square value. Okay. Okay, so to calculate chi-square, let me move this thing up here. We just follow this formula. So this just means sum up the square difference between observed and expected frequency. So observed minus expected frequency squared divided by the expected frequency. And we have to add them up for both groups, which is men and women. We have two groups. So let's have a look here. So for women, okay, this is for women. Okay, so it's just 1298 minus the expected, which is 1387 squared divided by 1387. This is men, okay? And this, I'm just walking you through the procedures, okay? Right? So it ends up being 7921 divided by 1387, which for each of them, right? Because it's both 89 squared. That's because we have the same numbers here. So 5.71 plus 5.71 is 11.42. That's our chi-square variable. And we already established that degrees of freedom is equal to 1. So the way we write this out is chi-square, parentheses, degrees of freedom equal 1. And sometimes you also see the sample size in here too, in this parentheses, equals 11.42. P equals, so for this, we need to look up the chi-square, need to look at a chi-square table to figure out the p-value corresponding to a chi-square of 11.42 with degrees of freedom equal 1. So let's do that. Okay, so here is a chi-square distribution. Okay, it's one-sided, so we have our region of rejection is right here, right? Okay, so what does 11.42 fall in the region of rejection here? To know this, we have a couple ways we can do it. There's the region of rejection, my fancy thing. So here's a chi-square table, and you could look it up. Your textbook also has one in the back. So just like all other tables, we find our degrees of freedom. We look at what our alpha level is. So we would have set it at 0.05, right? And so we can see that in order to reject the hypothesis, our chi-square value has to be greater than 3.841. And 11.42 is greater than 3.41. So we know that chi-square is less than 0.05, right? But so here's all of the views. We can actually go across here and see and go all the way here to where 0.001. So the chi-square value that corresponds to 0.001 is 10.001. 0.828. So we know that actually 11.42 corresponds to P less than 0.001. Okay. So I always forget I have animations, right? But I like to draw. Okay, so there's another way to do this if you're using statistical software, and we'll look at Jamovi in our example later, but all statistical software gives it. You can also go to this website and you can just plug in your value, your chi-square score and your degrees of freedom, and it will tell you that the p-value is 0.0007000727. So it's, and then you set your significance here. Okay. I also have a website where you can calculate it. You can plug it into my website, and you can also get the p-value to 4 decimal points. This place gives it to 6 decimal points. So depending what you're interested in. Okay. The way we'd express this is women were significantly less likely to hold full-time faculty positions than men were. And then you say chi-square, degrees of freedom equal 1, give the value p less than 0.001. So it looks like men are preferentially represented as full-time faculty. Okay, let's pause the recording here or stop it.